Hi, I'm Ian McCowan, and this is the Dissector overview video. Dissector is a hardware-independent GPU debugger, which means it can operate on any video card that supports DirectX 9 and doesn't use any special vendor-specific APIs. Dissector can hook into your application in two different ways. The simplest method is launching through the GUI, which uses DLL injection like most other GPU debuggers. You could also embed Dissector into your application through code instrumentation. This would allow you to turn on the debugger at any time without having to restart your application. In this video, we'll be launching an application from the GUI. Here we've launched the Microsoft HDR Cube Map sample. After hitting the capture button, we have a list of all draw events on the left and a list of render states for the currently selected event on the right. We can scroll through the list of draw calls, and the main application window will quickly update to show the main render target for that event. We can see the render state values for this call on the right. We can also change the value of render states and see the changes update instantly. No more fiddling with your application code just to test a few simple render state changes. Dissector also supports copying all render state values to the clipboard, allowing you to easily exchange information about render states with colleagues. Dissector has source-level shader debugging for both vertex and pixel shaders via shader bytecode manipulation. This means you get real hardware calculated values, not a CPU simulation. In addition to regular shader debugging, Dissector can perform a differential analysis of two shader runs. This can be done between any two shader runs, even if they come from different draw calls, use different shaders, or even if they come from different captures. In this demo, we'll try to discover why this dark line appears on the plane's wing. The analysis will tell you which shader source lines are executed in one run, but not the other, and if any shader source lines have significantly different results. The results tell us there are differences in the incoming normal and texture values, which means this line is painted in the texture and darkened a little bit by the lighting as well. Dissector can also help find out why pixels aren't being rendered. By changing render states, it can narrow down what is causing the pixel to not be rendered, including things like backface culling, stencil state, alpha testing, alpha blending, shader clipping, and more. In this example, Dissector tells us that the pixel isn't being rendered because of a shader clip instruction. If we look at the shader for this pixel, we can see that there is a shader clip instruction culling this pixel. If you'd like to download or get more information about Dissector, please visit the website in the video description.